When a physicist looks up at the night sky and those stars thousands of light years away, he's not seeing them in our real time. He's seeing them as they would appear thousands of years ago. But why is that? Well, he knows it's because of the speed of light in our universe. It's a constant. In fact, we're so sure it's a constant and we're so sure of its value that we've assigned a variable to it, c, 3 times 10 to the 8 meters per second, approximately. But why is the speed of light a constant? What particular value about our universe dictates that? What is light? First, we have to understand what is a wave. Well, if you've ever listened to music, you probably have heard waves before. Sound waves, produced by a speaker like this. The speaker cone oscillates back and forth with the musical signal, and that pushes the air, and we perceive that as sound. And that's called a longitudinal wave. But light is a very different type of wave, called a transverse wave. If you've ever thrown a stone into a pond, and it's created ripples propagating outward, that's a transverse wave. In waves, you can often vary the amplitude, like this, and the amplitude is, of course, the distance between the top of the wave and the middle of the graph. And you can also change things like the frequency, and make the waves cycle faster. And in changing the frequency necessarily makes the wavelength shorter, because the distance between these peaks is getting shorter as the frequency gets higher. So we end up with this equation used in waves. The speed is equal to the frequency times the wavelength. All electromagnetic waves are composed of electric fields, magnetic fields, and move in the direction that is the right hand, or the cross product of them both. To understand more about the electric field, magnetic field, and waves, we're going to have to look at a set of equations called Maxwell's equations. I'm not going to go into a ton of detail here, partially because it involves some particularly challenging math, but if one solves Maxwell's equations for the speed of the wave, you end up with this. As you can see, the equation for the speed of light depends on just 2 constants, epsilon naught and mu naught. Epsilon naught represents the distributed capacitance in a vacuum and is responsible for limiting how fast the electric field can propagate. And similarly, mu naught is the distributed inductance in a vacuum and is responsible for limiting the magnetic field. In the same way that sound is limited by the medium it travels in, air, there's a speed of sound because of the physical limitations, the physical material characteristics of our atmosphere. In the same way, the speed of light is determined by the characteristics of space, the characteristics of a vacuum. Those constants do matter, and they fundamentally set the speed limit of our universe.